All right, so today we'll be going over a lot of the basics. I hold on, let me switch it over. Okay, there we go. So this is all the stuff that I was asked to put together. Just as a forewarning, like usually, wonderful. Usually, I would each one of these would probably take an hour to an hour and a half to actually go through and walk you through. So I do have most of these on my YouTube channel, so you can go through, watch the tutorials in full, and really get a much better sense of how to actually do all of these operations. But mainly today, I just wanted to cover like really high level, all the things that you might be facing when you're taking more complex geometries, massing, and then putting it into Revit, as well as some other more specific technical things that I don't think I ever covered in my class. So today we'll be using these four programs primarily. So obviously Revit, I'm going to be using 2024. I'm going to be providing the families and the template and everything for you, but it'll be in 24. So just be aware of that if you're using a previous version. Rhino Inside, which if anyone hasn't downloaded that, that is the integration of Rhino and Grasshopper into the Revit environment. Very good. I'll show you one workflow, but I do have a lot of tutorials online on different stuff like creating structure, diagrids, facade systems, etc. PyRevit is also a really good one. So it's a PyRevit is actually it was built to be basically a native Python plugin for people to be able to create their own tools using Python. And so many people built so many really good plugin and tools that they basically integrated all those tools into their basic interface. So they have a ton of really helpful tools directly in the main software. And then Enscape, which is a rendering software very similar to Lumion. And then these are just a couple of the plugins, add-ons for Grasshopper. Lunchbox, I think, is the only one that I specifically use, but these are three others that you can all get from Food for Rhino. I'll be providing this presentation as well. So everything I have in here that's a link, I added the link to the top left for you to get. And again, this is my YouTube page. So basically, I think the last 3.5 or 4 semesters that I taught, I basically just recorded all my lectures because trying to teach software to 70 students is not very easy, especially over Zoom. So video tutorials was the easiest way, and then everybody could kind of go at their own pace. So I have a ton on here. I've linked all the relevant ones at the end of each section, but please check it out. So templates. So I'll cover this a little bit when I start getting to the demo, but templates are what you need to start your Revit file with. And so I will provide you with the template that I'm using, just so that if you guys are trying to follow along or trying to find something, you can at least have that as reference. The biggest thing to remember when using templates, and this is a question I got a million times, was why am I opening the template as a project? You need to hit new. It's going to open this window, and then you navigate to the template file and open it from there. Then that will essentially create a new project using the template as a base. There's also a ton of libraries. So when I was in school, you had to basically download the library of model components and detail components directly to your computer. Now everything past, I believe, 2021, you can access this Autodesk Family tool, which essentially is an online database of all the different elements within Revit. And so if you're trying to find anything, both model components, beams, columns, all that good stuff, as well as the detail components, which I'll show in a little bit, that is where you should start. Now, there's going to be components that are probably might not be in here. You might have to build yourself. Walls specifically and floors, there aren't any in here, but they're really easy to build. But things like your mass timber structure, like those can be found within here. So always start there, and then it's just a simple load, downloads directly into your project, and you can start using it. And then another thing that I just wanted to cover really quickly is the work sets. So if anybody doesn't know what work sets is, it's essentially layers, but for Revit. So when we work on a file, especially a large file, we break each part of the project into different work sets. It makes organization much better. It makes being able to turn things on and off much easier. So for example, right, like your site, your context buildings, you're not going to want that in every single view, drawing, etc. So you put that on another work set, you can turn them off, and basically it can turn all of those components on that work set off. So we use that a lot. This is a very personal thing, but the default work set name is work set 1. I will yell at anyone in my firm if I ever open a project and I see work set 1, because I don't know what the heck goes on that. So when you start, just please rename work set 1 to whatever element you want to work. It just makes it a lot easier. I'll get in and like 1,000 things are on work set 1. I'm like, well, what am I supposed to do? All right, so site. This is when I'll actually get into Revit. All right, so I pre-built this. So this is completely arbitrary. I kind of took the default site for this class, but I don't know if it actually is. And then the massing is totally arbitrary, but I try to get it close to at least the program requirements. So I have that file, which I'll be using as kind of like a cheat to potentially copy things in. But I do have basically a brand new file right here. So the first thing that you want to do when you start a project is you want to set the location. So under manage, you have this location and project location. So you go here, and then you basically just type in the address of your project. So that sets the address. It also finds the closest weather station to that address and assigns it to your project, so that it actually brings in all of the environmental data and coordinates to your project. So when you're doing solar studies, it's accurate, as well as a couple other things. But that's the primary one for that. And then we'll start to do site. So the site, there's a couple ways to do site. So obviously you can build the site totally from scratch, which you can do under massing and site under topo solid. But you can also bring in a CAD file with topo. So in practice, pretty much every time we start a project, we get a survey. That survey comes to our civil engineer in a form of a CAD file. It has all the topographical information as well as the GIS information. So we can use that as a baseline for our projects. So you can create from import and then create from CAD. I skipped a step, so we have to import the CAD into the file. So insert, and then import CAD. And then I'll go back. Oh, there we go. Okay, so I pre-built this one. Now, when you bring in CAD files, especially surveys, their origin can be like several miles away. So personally, I just do center to center. And then you basically, as long as you're aware and comfortable with the import units, just make sure that those are correct. Then you can import that. And then once you import it, so this is what a typical survey file is going to look like. So I've cleaned it up a lot, but a lot of times what you're going to have your topography contours at the true elevation that they are in the world, and then all of your kind of road work and everything else at 0. So what we need to do is set up our project so that the starting point, the 0 mark, is at that elevation that we're going to be working at. So to do that, what we have to do is go into our visibility graphics and turn on our project base point and survey point. So underneath site in your visibility graphics, you have a bunch of different stuff, but mainly your project base point and survey point. So the project base point and survey point are for, there we go, for you, is that in there? Where is my survey point? And this is the wonderful thing about live demos. Did I hide it? Yeah, I hid it. Of course I hid it. Okay. All right, there we go. So, and of course, this does not come in at the right scale. So always want to make sure that it is coming in typically at feet. There we go. That makes a lot more sense. So when you first start a project, your survey point is going to be at the same point as your project base point. So what you want to do is move that, and you want to move the survey point specifically, not your project base point, down. And so what we typically do is we'll wait until we get the survey and then import the survey and then move that down approximately however far we need to. So I believe that was 720 feet below. So then we need to move our topography down to that survey point. So now our survey point is lower, but our project base point is still at 0. So that's really important because when we're doing projects, our projects need to be at the correct survey elevation, right? So when they're setting what is called the FFE, the finished floor elevation of the building, and when our civil engineers are starting to do all the grading and actually making the topography work for our project, they need those true elevations. That's what they go off of. So we need to make sure that our projects are set up correctly, and then they will actually translate to things like the levels, and you can actually drop spot elevations around there. So now that we have it in the approximate location, what we're going to do is we're going to rotate the topo. So within the project base point, you can set the angle to true north. So that allows you to essentially orient the site correctly, the sun correctly, but keep your building orthogonal so that it's much easier to model things and develop your documents. So ultimately, what the survey is going to bring in, it's going to be at true north, so you need to rotate it to fit your project. And I've already set the project base point.
What is it drawing that? Site that you made that. That's your model.
Yeah, what do you mean?
Site model.
The site? Yeah, that's a CAD file we have of Uptown. This is Uptown Charlotte. You okay? All right, so I'm just gonna draw this, get a random center point. Again, you can be a lot more specific, but what you got to make sure is whatever you're rotating to, you want to write that down, 42.81 degrees. So I'll rotate the topography. You can move it. And then what you got to do is essentially go into your project base point and under here set negative 42.81 degrees. Of course, that's going to depend on whatever your project is and where your project is. Of course, we could have rotated this 90 degrees, whatever basically works best for where or how your building is laid out. So the nice thing about that is when we go into our site plan, I already had the CAD in here. Oh, that's fun. All right. So when we go in here, I'm going to turn the view template off real quick. So in our properties for floor plans, we have an orientation category. So right now it's at project north. That is your north for your project, your building itself. But we can set that to true north. And when we do that, it angles to the correct orientation. So when you're doing site plans like this, you want it to be true north. And so that's how we do it really quickly, really easily, without having to set up our project in a really weird, funky angle that is almost impossible to model with. All right, so now that we have the CAD file, our site parameters all established, we can build our topo. So again, you can build your topo from scratch. You can build it from a CAD file. You can also create it from CAD file. So you create from CAD, you select the file, and then what it's going to bring up is all the layers within that CAD file. So you do not need all those. All you need are the contours. So the two I need are these two. Hit OK. And then it's going to run. Now, if you're working on a project or a Revit Revit 2022 or earlier, and maybe 23. It's a surface, topo surface, but 24 and beyond is a topo solid. There's subtle variations between, but mainly why they made this change was so that when you're cutting roads and everything, you can actually have thicknesses to them, create offsets to them, which helps with visualization. So it's going to come in like this. Really nice, neat. Of course, a lot of times when it comes in from CAD, it brings a ton of points, which I typically always go in and delete a ton of them and just keep the main contour points. And then also it's going to be a little bit funky depending on how it comes in. So what you can do is basically go in, modify the sub elements, which will bring up all the points that are generating this topo solid, and you can manipulate them however you need. So each one has an elevation according to it, and then you can just change the elevation and it will update. Now, the Topo Solid is pretty heavy in terms of how much computing power it takes. So that's why I like to eliminate. And they also, Autodesk learned from this a little bit, and they have a simplified Topo Solid tool, which you can actually, it goes in and removes a certain percentage of your control points, which is nice because then it can start to simplify. We've also built Grasshopper scripts that actually rebuild the topo surface into much cleaner, simpler files. But I am going to cheat a little bit because I went in over the weekend and cleaned up that topo surface and simplified it a lot. And again, this is one of those things that will take an hour or so to go in and actually clean up. So just trying to get everything into the time. And of course, the recording software also lags my mouse, so apologies. All right, that's okay. All right, and then again, work sets are very important. So, like I said before, site is definitely one that you want to have on a separate work set, and also CAD. So I have gone in and set up a bunch of different work sets. You can navigate to that in the Collaborate tab or in this little button down here. And then you can change it however you need. You can also, what's really nice, you can default that work set to be either on or off in all views. So things like rendering entourage or anything like that, where you know that's only going to be in your perspectives, you can turn that visible in all views off, so that you don't have to keep going into your visibility graphics and turning it off every time. Right down here is where you can see where the active work set is. So that is the work set that's going to be applied to anything that you're drawing. So if I'm starting to draw, or just like I did, I copied this in, it's going to be set to the Architecture Core website or work set. But you can change the work set that's applied just in the properties. I'll just turn that to site as well as these. I'll keep that on. What does it come in as pinned? Oh. Okay. So visibility graphics, I kind of blurred over it a little bit. I'm going to get into a little bit more detail when we start to talk about perspectives and setting up your views. But it's basically broken into a bunch of different categories. The main couple are your model and annotation. So this is every single model and annotation component that lives within Revit. So if you need to turn off something very specific like floors or walls or columns, you can actually go in and turn those off. You can also override the graphics of those components. So you can actually change the line weights of all of them, the surface patterns, transparency, and also how they cut. You also imported categories, essentially anything that you import. So CAD is going to show up here. So that is the file that I had. So I'm going to turn that off. And then, of course, you can also turn off the work sets as well. And they come in as a bunch of different stuff. Let's see. Okay. So I have that on. I'm going to turn off the site parameters now since I have successfully set up my base project correctly. All right, so now that I have my site, I have something to start working off of. What I would recommend is that you start to establish your Revit to Rhino workflows. So I know most of you, if not all of you, have been doing your massing studies in Rhino. You guys got complex geometries. So what is really nice is to be able to basically take the site, either if you've already started building your site in Rhino, import it into Revit, and then vice versa. And then the other really nice thing about that is you're able to set up and start modeling, positioning things that relate back from one another. So instead of having to import and then have to drag it over and set it in the correct place, it'll essentially link the origin coordinates so that everything that you're modeling is in the same place within both programs. So I'll start off with like a really simple exercise, which is essentially just exporting a whatever file you have. So when you're exporting geometry CAD from Revit, it's going to take the geometry that is visible within the view that you have open or selected. So you don't have to like highlight anything, whatnot. You just have to make sure that everything that you want to export is within that view and is turned on. So it'll be under File Export, CAD Formats, and then you have a bunch of different options. I still find that DWGs are the best, especially when you're importing geometry from Rhino. But this is where your views will come up. So you can only export CAD files, 3D CAD files from 3D views, but you can select others if you need to do like a CAD plan. And then this little ... Revit loves hiding really important buttons in the smallest, most nondescript buttons ever. And I'll show you that in a little bit. But the ... basically opens up all the different settings that you can change and manipulate. The biggest one is solids. So if you're not getting the geometry that you want out of it, go to the solids and try both different typologies. I find that ACIS solids work the best in there, and then you hit just next, and then it will export, and then I think I saved these in my own slide. Yeah. So you just hit OK. And I also hate that Revit likes to name my files. So I will just do that. There we go. All right, and then, so this is just the Rhino base. So you can literally just open the AutoCAD file directly into the environment, or you of course can import it into the Rhino project that you have already. So all you gotta do, open, make sure all those are correct. Yes, you want feet. And then that will import your file into Revit, or Rhino, excuse me. Now, of course, you have all the different layers that it comes in on, so it actually does bring in your contours as well. So if you want to rebuild that surface, maybe simplify it a little bit, you can do that within Rhino. And then I'm going to go back to my other file. Oh, wait, no, that was the wrong one. So again, I just made a quick massing. And that one. So you can see here that I brought that in, brought the topo in. I built the Rhino model directly on the site in the relative position that I wanted it from. And then when you're exporting from Rhino, of course, you need to highlight the elements that you want. That's why it says export selected. And then when you're saving it, so again, you can try any file type that you want. I personally find that AutoCAD is still the best. However, there is a specific type. So if you go under options, this should populate automatically, but if you have turned off the dialog thing, it won't show up. But it usually comes up as default, but when you're doing solids, I always find that 2007 solids, for some reason, the settings that are in there, it works the best. It is the most successful when bringing in solid geometry, especially more complex geometry. So then you go back to Revit, insert, import CAD, and massing export. And then this is where you want to make sure that your origin to origin. So this is where the two origins actually start to work for you, and you're able to bring it in directly in the same place. And of course, I'm going to say that it's probably going to pop up in a wrong place. But hey, there we go. So so it populates here. It comes in as a solid. Now you can see that the geometry is this really ugly black maroon gross color. Uh, and a lot of people can't figure out how to change the material of that. So I'm going to quickly show you how to do that. And then I'm going to show you how to actually import the geometry so that you can utilize it for your building massing and actually create Revit elements out of it. Because right now, when you just import directly into the project environment, it's basically just solid. So if you're importing like structural elements or maybe facade elements, something very custom, that's okay, because you can still manipulate the materials and everything like that. But if you want to build Revit elements from that, we'll have to do something a little bit different. But again, there is no like materials and properties, anything like that. What you have to do is go into your Manage tab and then Object Styles. And then again, it's a little bit buried, so you have to go to Imported Objects. And then it will be in here. So basically all the CAD files, everything that you import is within here. And then underneath the plus is all the layers. So whatever layer that is under, that is the materials that it's going to be associating with. So again, it defaults to these render materials that are just absolutely terrible. So I have set up a masking material, and if time allows, I'll get a little bit more into the materials itself. And then I'm just going to copy it into both layers since I can't remember which one I actually did. And again, you can also change the line weights and the line colors and all that associated with it. So if you're bringing in 2D CAD files, you can manipulate the line weights of those 2D CAD files. So press OK, and then voila, you get a nice material. It's got, you know, the typical white massing associated with it. But again, that's not how we bring in massing when we want to actually manipulate it. When we want to manipulate it, we go into the in-place mass environment. So we're essentially going to be importing that CAD into a conceptual mass. And when it's in the conceptual mass, you can then start to manipulate mass floors, curtain systems, etc. So I'll just do mass 1. And then just do the same exact thing that I just did. Import the mass, auto origin. All right, and now since I set that material, it's automatically applied to it. And so while it's in here, I can actually go in and start to select specific faces, start to break those faces up into different curtain walls, which I'll show you once I get to the enclosure section. But when I finish this mass, now what I can do is I can highlight that and I can actually assign mass floors. So if you have a really complex mass, that's a really nice way to be able to get all of the floor boundaries of the of your floors within a very complex geometry. So levels, I'm not going to explain how to create a level. I hope that should have been covered in your computational practice before. However, if it will let me for some reason, there we go. So I'm just going to do 20 foot first floor, and then 15 fluid floors. I know this is really riveting stuff. I do have some videos linked in the presentation that walks you through how to set up your basically set up all of the massing, the levels, your grids, everything within Rhino inside so that it's all parametric. Let's see. Yep. So we want to call that guy roof, of course. All right. So now that we have the levels set up, then we can go back in to our massing environment and hit mass floors, and then select all the floors that we want it to create a mass floor on. Press OK. So now you have floors, and then you can apply floors directly to that using the floor component, but not just the floor component, floor by face. So if you go in floor by face, I have created a CLT floor slab, which you should be able to set up pretty easily. But you highlight all the floors, mass floors, you hit create floor, and then it will actually go in and create all the floors within that boundary. And you can, this guy's going to be a pain in the butt. And then you can go in and actually edit the parameters. So if something's not exactly right, you can still go in, edit the boundary, and it will allow you to manipulate it however you need. So that's how to manually import geometry into Revit. Again, importing it into the conceptual mass is one of the unique ways that you can take Rhino geometry, import it, and actually be able to utilize it. Most of the other times, you're essentially just taking something that you can't model in Revit and just importing it into the Revit environment from a visual standpoint. But this is the one part of the presentation that I will show you Rhino inside. So if anybody has not used Rhino inside, so there's a couple, obviously Rhino and Grasshopper are in there, but there's a couple other tools that you can use. And then you launch it directly from Revit. So I will open both Grasshopper as well as Rhino. And then I'll show. So I've set up a couple workflows that I'll send out. They're very simple, but again, it does make the transition between modeling and Rhino, modeling Revit even more streamlined. So let's see if I can do split screen. Now, this is personally my preferred way to do it because everything links in perfectly, and also you can be much more specific about what elements are actually assigned to which layers. So I'm not going to I'm not going to describe how this is built, but essentially you're able to select the type of Revit element, and then you can actually assign not only the geometry, but also you can create custom layer names, layer colors, and then all you got to do is press this button and it loads directly into Rhino. So I did that with two. So the one on the top is taking all of the components. And they're still working out a little bit of the bugs. But the other one, the one that's below that is essentially you have to manually select the components. So for some reason, all of the topo solid gets recognized when you do the top one. So what you can do is actually select the road itself And then if we pull wherever Rhino is, we pull that back up, we now are able to get that back in there. So again, you cannot, it doesn't have to be limited to your topography. It can be anything. If you create a mass within Rhino and you want to bring it into a mass in Revit or any sort of elements you want to bring it in to be able to use as a reference. So let's say, you created all those mass floors. Now you want to bring in all those mass floors into the environment. What you can do is just go back, select all the floors, and select this specific type. So now it's starting to link in there, and then I can actually just go in, just change the color of it, and now all those floors that we just created in Revit are within the Rhino environment. So now I can do whatever I need to within Rhino, create some crazy nerve curves, whatever. And then, of course, you can then go back from Rhino and go into Revit. That workflow is a lot simpler. Back to Revit. So again, this is it. You don't really get any of the functionality that you get by importing directly into the conceptual mass environment. But if you are just bringing in elements, this is a pretty easy way to do so. So all I got to do, right click, set one brep, select whichever component you want to bring in. And then if we go back to the Revit environment, of course, I'm going to break my computer doing this now. Yep. Just close. It's because you have to make sure that you're selecting the right assigned to the solid. There we go. And my Rhino close. But essentially, and again, I have all of these workflows on YouTube, so you can do that. But essentially, it just brings it in directly into the environment, just like you would import CAD, and you can manipulate the materials and everything from there. So those workflows are really good. It really streamlines the entire process. You don't have to go through exports, imports every single time you are working on your files. All right, so got through Rhino to Revit. All right, so structure. So very important for y'all. So for structure, what I'm going to do really quick is I'm going to create all of my plans and RCPs because I will need to do that to be able to populate all those. So you can highlight all of them. It'll create your floor plans and then do the same thing for RCPs. So we'll go to level 1. And then I'll also create one more. I turned off elevations. But I'm going to create one more elevation. I have one already set up. Again, that should be pretty simple and should be directly from your computational practice. All right, so this is a short face. I'm a little OCD about making sure my stuff is named properly. All right, so first thing you want to do, as always, and this is what we do in practice every single time we start a project, is set up your grids. It is very, 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 very important, especially if you're creating structural components, because they are able to be tied to the grids themselves. And so you want to make sure that your grids are set up properly so that all of your structural components respond to those. So I'm just going to do a very simple 30-foot grid. And yes, I know I can array them, but I'm going to be a manual guy for right now.
Can you make it a free plan?
A what plan?
Can you set the edge of the floor plate just out from the grid?
Yeah. So as you can see, there's a little bit of distance. So I'm going to shift. So yeah, that's a very important thing. He beat me to it. So I've set up my conceptual mass so that it is the full extent of my structural grid plus 2.5 feet on either side. The reason for doing so is because, actually, I'm going to move the grids. Sorry. The reason for doing so is because almost never do you actually put a structural grid or an envelope on a structural grid. Your structure is most likely, if not always, going to be behind your skin. And so you want to set up your massing to reflect that. So right now, I'm just going to offset those 2 feet 6 inches or 2.5. And I was angled, of course. And if anybody doesn't know the filter tool, get to know it because it is one of the most helpful tools in Revit. That's another thing too, not only for your structural grid, but also as you're starting to design your facade system and start to set up potentially the exoskeleton for your facade, you'll probably want to create multiple conceptual masses that have different offsets of the mass so that each of those elements are associated with the correct depth from each other. So like in the original model that I had up there, the exoskeleton and the curtain wall system are in the same exact plane, which don't actually work. You can offset them from that plane, but then the corners get all weird and it doesn't work very well. So
I'm sorry, you set the square grid, but you would not. It wouldn't be square, right? That's the structure. More rectilinear.
I mean, it totally depends. So 30 by 30 is the max. Well, it's the max grid size that we typically use. It's also one of the most typical layout, like grid layouts for offices. So a lot of like office furniture, all those systems are designed around that kind of grid system. Now the core, like in a steel building, our cores are typically deeper. Sometimes the depth of our from the core to the envelope is like 45 feet. It all depends. Again, going back to last week, your structural system, if you look into and research the depths of those, the depths of the structure that you need and the spanning capabilities, then of course you can do a bunch of different stuff. Now, with mass timber, you want to try and keep it orthogonal, but you I mean, it's academia, so you can be a little bit funky if you want. You just got to figure out how you would actually do that within.
This is one way you could actually make one bay larger.
Yeah, so I'll show you that too. So once I get into, I'll just do that for fun. So right.
Be more efficient with the vertical structure.
Yeah. I'm just gonna hide the math real quick. What is
CLT's on one way, right?
CLT is one way, but the math split. All right.
It's just something that Thaddeus will talk to them about, right?
Yeah.
Like you don't make an equal like square grid.
I mean, you can. Yeah. Now you're not going to have the same exact beams going both ways, which I'll show in a second. So I don't know why the heck this is not showing. Give me one moment. I don't know why this is a pain in my butt. In any case, so I'm going to make sure that the grids are on shared levels and grids. I'm not really sure why these are disappearing for some reason. I'll try and figure that out. Let's see if I get to another one. Good times. All right. So when you're starting your structure, so when I am doing structure, a lot of people kind of automatically default to the architectural columns, but they are only for show, right? So anytime you're using them in a Revit model, those are going to be purely aesthetic. You want to use the structural columns to actually create the columns and the beams and all that. Of course, in real life, your structural engineer is going to be doing that, but we still do have to place them, especially when we're starting a project. The structural engineer is not on board yet, and we obviously need to show structure. So when you select the main beam, so what you want to be aware of is, for some reason, it selects depth over height when you first bring it in. So that is right here. And then you want to change the height of the column to be the level above. And then finally, you want to select at columns. So this is where you can select all of the uh, the grids, and it will place a column at every single intersection of the grids. And they're also then tied to those grids. So when I hit finish, and for Peter's sake, if I just move this guy down 5 feet, all those columns move along with it. That goes for any beams that we'll put together. They're also going to be linked to your grid. So again, you can play around with that, and again, it's just making it somewhat parametric so that and linking these things together so that your files are all nice and neat, and you can adjust and edit all of them. And this is not only for, so the reason why I set up those elevations, and I will turn on my site for right now. So there's a couple different ways. So you want to be able to manipulate your structure. And then that's one of the nice things about doing it out of Revit elements and not just trying to do it in Rhino, because Revit has inherently a ton of parameters. It's a building information modeling. You are designing with all the different parameters that could be associated with a building component. So you can select all of your columns, and within the columns themselves are different parameters. Of course, you can change what level you want them to be associated with. So if you want it to go all the way up to 5, you can do that. But what we typically do, on what the structural engineer will do, is associate that however they need. So you can either attach the columns to a floor or roof slab. That will automatically link it to that slab. So if I move this slab down, all those will move along with it. Now, sometimes that's good, sometimes that's bad. Typically, I will just figure out the offset of the slab, so essentially the thickness of the slab, and then change the vertical offset to be that thickness. So now all of them are sitting directly underneath the CLT. Now, again, sometimes depending on your structural system, the columns will be going through your floor slabs. That's something y'all have to figure out. Remember that detail that Peter showed, where it had the connection that was actually going through the slab, and then the next column was connecting down to it. It really is up to how you want to model it, but that is up to you. So then once we have our columns, now I'm just showing the same size column everywhere, but of course in real life, the columns would start off larger and then get smaller as you go up. So what I just did, I just copied all those, and then you can paste to either the current view, which pastes it to the selected level. And then what you want to make sure is when you're pasting these things, especially if they have associated heights to them, is that you reassociate the columns to be associated with the level heights that you have set. So, of course, typically your first level is taller, and then your typical floors are more average, well, for offices, they're between 14 to 16 feet tall. And then once you have all of those columns that you want on your typical floors, you can just group them all together. And then columns. And then you do the same thing where you copy, Control C, and then paste to selected levels. So that allows you to go in and select several different levels at one time and paste all of them to them. So now all they're together, and of course at the top, oh yeah, those are all the same. All right. So those are columns. Within each column, so again, you can go into, if you go into the, I guess I'm doing fine on time. If you go into Insert and then Load Autodesk Family, so all those, so again, do not just hit columns. Those are the architectural columns. Go down to your structural columns, and then you can go and find all the different dimensional lumber, glulam. So I just used I think the Southern Yellow Pine, but you can just select, load, and I'll load it in. And then of course you can go in and select, it comes in with pretty much every size, nominal size that it has within its library, but you can get in there and start to manipulate the depth and height depending on your requirements, which you can do in the B and D parameters. So for columns, it's pretty straightforward. For beams, it can get a little bit more complex. So let me go to, let me see. Nope. All right. So I'm going to go to my level 1. All right. So I have my layout. Just going to hide those real quick. The grids are really throwing me off. I do not know why that's happening. But anyway, so when we're doing beams, so this is all going to depend on the structural system that you specify. If you're going to do a one-way mass timber structure versus two-way, and then of course like the spacing of which I'm just going to do what we traditionally do, which will show you a couple different things. So I'm going to select for my primary beams. I'm going to start out with the primary beams. So those are typically the larger ones, and they're only going to be going in one direction. So you're going to select the grids that you want those beams to be aligned with, and then hit finish, and then they'll all be associated with those grids, and they'll all be broken down into the parts associated with it. Now, typically when we are doing structure and when we're laying out a two-way system, which relies on both the primary beams but also intermediate purlins, we will break the beams into two, put it on either side of the column so that we can run our purlins directly into that beam and not have to worry about accommodating the column and being a little bit more consistent uh, with our connections and the purlin lengths. So I'm just going to go in, select all of the beams. And thinking back, I could also have just done this, right click, select all instances, and then visible. And then this is where those parameters really come into play. So you can just move and just shift them over. You can also specify using some of the offsets within the components. So I think it's like -11 and a half. We'll shift it all the way over. And then I'll also change that top offset value. So again, right now the beams are literally sitting in the same plane as the floor slab. So we want to shift those beams down so that the CLT is actually resting on top of the glue lambs. So 9 3/4. And then again, I want to have my beams on either side of the columns. So I will just copy and then paste and then just change that negative to a positive. And now I have beams on either side of my columns and they are ready for my purlins. Now, you can also change, so at the ends, right? So especially in this kind of configuration, not necessarily if it's going directly into the column, but if they are on the side like that, you can cantilever the beams out from the columns, and you can do so by just changing either the start or end join cutback. So let me see if I selected the right one. I did, but I had the wrong negative. And of course, that's the wrong. There's going to be a lot of trial and error in Revit. It all depends on the way that you draw them, the way that it reads the grids, the direction of the grids. But okay, so now I have my primary beams. They're all approximately offset and they're placed. Yep, that's not right. There we go. So I want to edit the work plane. So again, all these are associated. Revit really works with planes and predominantly two-dimensional planes. So you can go and select the plane that you want it to be associated with. And then, yep, 0. So now it's correct. Now, of course, you'll want to select the work plane before you start, but if not, then you can go and do so after the fact. And then now we will do the purlins. I'm just going to make sure that that's selected first. So purlins, they are not always going to be associated with the grids. So I'm going to do a couple just to show you the different ways that you can do it. So purlins, you will almost always have as smaller beams. Now, of course, they can be the same depth, but not always the same width because they're carrying a lighter load. So I've gone in, selected or highlighted them all in the opposite direction of the primary beams. And then I'm just going to copy them down right now at 10-foot intervals. Now like how those are placed and how they're spaced really depends on your project. So like for the River District project, we actually have the purlins in a completely different spacing than the grids, and they actually extend a little bit past, and then the CLT, they stop, and the CLT actually spans over them, and it creates a really nice channel for our main HVAC systems when they're running along the core. But again,
But you could do it without purlins, right?
yeah, as I said, one way or two way.
And if you made it, you'd have to maybe add an extra, it would be 7 layers or 5 layers.
Correct. Yeah. So right now the CLT would. Oh God, the lag is killing me. I'm just going to point here. So. So right now in this configuration, so your primary beams are running up and down, your purlins are running this way. The reason why your purlins are running east-west is because your CLT is actually sitting on top of them in this direction. So they're being cantilevered, spanning between these two purlins. if you were to do a one-way slab, you essentially, depending on how you want your CLT to be oriented, then they would actually.
I don't know.
So your CLT would be running this way, but again, your CLT can only span so far. So if you're going to do a one-way slab, typically your primary beams are going to be closer together so that the CLT can actually span, and then you're all going to be using either a 5-ply or a 7-ply, depending on what you want to do. I have 5-ply in there right now, even though it's a two-way system, because I know the structural requirements, seismic requirements are a little bit higher, so that just provides a little bit more rigidity to your structural diaphragm. And then if you want to be super specific, since realistically these the purlins are not supposed to run into or through the beams, but they're supposed to sit on the face, you can then offset all these. So if there's two different things. So one is your little blue dot right there. That's connected to your structural grid. That's the thing that's linking it to the grid. So don't move that. But you can change this little offset slider that essentially pulls the model geometry back from the grid. And so when I do that, it'll populate the dimension automatically right there. And so because of that, now that I know the dimension, I can just select all, visible, and then it's going to be a pain in the butt. But essentially, let's just do this one for right now. I can change all those to 1'11". They'll all automatically pull back and sit on the face of the structure. So now instead of running through the beams, they're sitting flush. And of course, you could do it to the opposite face as well. For time, I will not. Okay, so the other thing, and this is something that, and I have to change the Z offset so that they're sitting underneath the slab. So again, Z offset, negative, whatever your depth is. All right, so I always validate what I'm doing in 3 dimensions. That is one of the big benefits of Revit, is being able to find and be able to visualize what you're drawing in 3 dimensions in real time. A lot of people, they will just constantly run into issues and then not be able to figure it out. And every time I just go into the 3D view and it's glaring them in the face. All right, so again, if you have a typical structural layout, you can just group them. This is saying it's going to detach from grids. That's not great, but just for a sample, let's just say beams, whatnot. And then again, you can just populate. What happened now? I selected all of my columns along with my beams. All right, so now I have beams. So now I can group them. Copy, and then again, paste it selected. Select all the floors that I need them to be on. And then because all of my floor slabs are going to be approximately the same depth, and they should be, even if you have different structural column sizes and beams, then all of them should be associated. Of course they're not. Let's see. So this was one thing that I have in my presentation that I just forgot about. So when you copy these up, sometimes they will associate with the right floor. Sometimes they will associate with the right floor. Sometimes they will associate with the floor that it was copied from. So just be aware of that and make sure that they are not. So, and of course, this is going to take forever. Let me see if I can just copy them in from the other. This is another thing I might point out. So, like I mentioned in the beginning, with the different with PyRevit and the different functionalities it has, one thing that it has that especially for working in multiple projects or families, it's like a lifesaver with these new tabs is it will color the tabs for you. So you can see here that I have the red and blue. So before, all of them are the same color, and it's almost impossible to figure out what project is what. So now we can associate colors, and of course you can go in and edit the color graphics if you want. Now I am going to just go in. It's probably not going to work, but that's okay. Actually, it's not going to work. All right, so I'm just going to cheat and just copy all these. Now, if you build it in Rhino Inside, you don't have to worry about this. All right, let's go. All right, that's close enough. Of course, you have to put a roof on here. So roofs act a little bit different than your floors. So floors, the top face of the floor is going to be at the level grid, and then all the thickness is going to be below. Roofs act the opposite. So they're actually, the bottom of the roof is going to be at the floor level, or the grid level, excuse me, and then it's going to be, and again, I like to draw in 3D. All right. So in the essence of time, the other thing with structure that is a little bit funky with Revit is diagonal bracing. So again, structural engineer is typically going to be doing this. However, you need to work with your structural engineer to figure out not only the form of the bracing, but also the location. So the bracing typically in traditional buildings, high rise is a bit different, but typically you need at least 2 braces in each direction, or 2 to 4. That again, right now your structure is really flimsy in the lateral movements, so that diagonal bracing stiffens it up. You can also do shear walls. So you can do shear walls. They act very similar. However, just be aware that shear walls, they're not just walls. They have to have, or they typically have some sort of tails on them. So they create like C shapes essentially so that they're a little bit stiffer. So when you're doing diagonal bracing, I almost always will model it in elevation. I just got to adjust my view. All right, so in structure, there is a tool called brace. So that just opens it up and automatically associates the structural beam as diagonal bracing. And then you want to pick a plane. So you want to select the grid that you want to be working on. And then instead of having to rely on the grids, you can actually just draw the bracing itself. And again, bracing, as long as it spans between the structural bays, or structural grids between the columns, you can do a variety of triangular shapes depending on the function of your building. So, a lot of times bracing will go from beam to beam like that. But if you have a doorway down in the center, you can also do something like this. And then you can also start to manipulate the ends so that they are visually more realistic. Now, in reality, they actually are going to be offset like this. They're actually probably going to be offset a little bit more like this too, because they have to provide room for the connections to actually apply and connect the beam to the column. But for visual sake, I'm just going to set them in there. All right. And then again, copy and paste is your friend. So right now they're associated with level 1. We can associate it with level 2. Now it probably, because the floors are different sizes, they'll come in like that. But all we have to do is drag those down and be done. Now, of course, where those start to come in are going to be dependent on what it's connecting to. So if it's connecting to the beam, it's going to be probably sitting a little bit back from the bottom of the beam. Right now, since we have those double beams on either side of the column, they'll likely rest in there. And again, it just really depends on what you want. And I always get the negatives right. There we go. All right. So then now that you have them in your favor, so I'm just going to copy all the way up. And then what we typically do is, since these are all the same, let's copy them, group them, so that I can basically mirror them onto the other side. And this is a good point to also talk about reference planes. So in every single project that we do, or in most projects that we do at least, the good ones, we create reference planes at the center line of the building. It just really helps out when you're modeling, and I have reference planes turned off. And this is a fun part of using view templates, is forgetting what you turned on and off. So reference planes act, like they said, a plane, so you can actually draw on them. So if you're trying to do a unique elements, like unique, especially if you're doing like curvature or something like that, you can create a plane, name it, and then draw on it. It can be at whatever angle you want. It can also be at in the horizontal or at an angle in the vertical as well. So for them to show up in your work planes, you have to name them. So we just typically will name them centerline long, centerline short. And then we can use them to do a bunch of things, but what we typically will do, especially if we have elements like this, are just mirror across. All right, and then like I mentioned, you'll want to have bracing in some respect, whether that be with diagonal bracing or with shear walls in at least 4 bays. Again, you can talk to David about what will meet the requirements of your specific building. But For time's sake, I'm just going to copy this. But again, you can do whatever variation you want. So a lot of times, especially around the core, we'll try and hide the bracing. Let's see if this works. Hey, look at that. We'll try and hide the bracing within a wall. So like a wall that's adjacent to a stair, anything that the bracing isn't going to interrupt a programmatic element of, we try and hide it there. But again, a lot of times, like especially in the core, you have a ton of, that's pretty close. You have a ton of doors. You have a lot of rooms, right? You have your mechanical, your electrical room, your IDF closet. You have bathrooms. You have your elevator lobby, and so you have to work with your structural engineer so that all of the program and the circulation into the program works for with the bracing. And a lot of times too, if you're not working with a tower shape like this, and you have like much more a larger, a lot of times your bracing is going to be interrupting program and like basically diving down in it. So again, coordination with your engineers is very important. But again, thinking through this in the early stages helps to alleviate some of those problems that you run down or run into. All right, bracing. All right, so the funnest part of projects is the core. All right, how about this? How about I need to go to the bathroom, so I'm going to take a quick break. So I'm just going to run. So the presentation, the workshop, or the workbook that I set up. So this parallels what I just walked through. So it should be a good cheat sheet for you to reference as you're trying to set up all of these. And then again, I have tags. So with the topo solid, that wasn't around when I was teaching the course, so I did not cover it. But of course, there are a ton of YouTube tutorials out there that you can look at and walk through with them to figure out how best to utilize it. Balkan Architect is one of the best, in my opinion. Nope. All right. Oh, I forgot to do that. Well, I'll go back. So one thing I did not do, but I'll just cover real quick, is context. So context is really important, of course. Now, there might be somewhere floating, and where is their site? Is it in Uptown? Or? It's a train station. Which one? Oh, like the, okay. Oh, like, yeah. So like, yeah, okay. Yeah, then I don't have the model for that. But so Formit is basically the SketchUp of Revit Autodesk version, but it does have a couple really cool features. One of which is context building. So you can set the location in Formit. You basically open it directly in Revit, and then you can model things. So of course you can do more freeform modeling, but you can also use the location. You'll get an aerial, you get terrain, and then you also can get context buildings. Now, these are the context buildings that they're getting from, I believe, OpenStreetMaps, which is this guy right here, which is a really great resource. But they're not perfect unless it's like a really dense, like New York City, really popular metropolis where people go in and actually update the models. It's going to be pretty simple massing, but you can get a really large massing model of all the context of approximately the correct scale. And then you can go in and start to manipulate, and I'm sure they probably already have this a little bit, but start to detail the buildings that are actually like adjacent to your property, and then use the rest as just kind of background massing. And then you can import that directly into the Revit environment. Again, you can get terrain, but I wouldn't necessarily trust it, especially for site specific. And then there's an OpenStreetMap, really good resource. It's open source, so anyone can input data into this. So it has a ton of like the same information you would find on Google Maps. Okay, I'm recording. But it also has some three-dimensional capabilities as well. This is what the plugin pulls the geometry from. So again, this goes through all that. Again, I do have several YouTube videos for all of these parts and pieces, and it goes into much greater detail of how to use that. And then same thing with structure. And again, so you can do all of this within Rhino inside. You can make it fully parametric. You can do really unique structural grids. You can do exoskeletons. You can have all the floor slabs be parametric. And the nice thing about Rhino inside is it imports all of your native Revit elements, so you can associate all the floor slabs, structural columns, all that directly into the Rhino inside environment. And then this, so I just want to touch upon this briefly because I built a family for this project. I'm not going to get into how to build it because it's a little bit unique. But there are, you can create custom families. Did they go over this in Comprac, like the generic model adapted families? Yeah. So this is a great resource if you have, if you want to build not just these weird funky panels, but like exoskeletons. It's really good for. You can change the profile of the beams. You can change which direction it goes into. You can change the offset. So we don't use it a ton because we don't do exoskeletons a ton, but it's a really good resource for doing those unique frames. All right, so core elements. Go back to Revit. I'm just going to close Rhino so it doesn't slow anything down. All right, so your core, the location of which is going to depend on what your building looks like and how you want to operate it from. So typically the core is going to be in the middle, but of course you have side cores, you have end cores. Really just depends on your floor plate and how you want to do it. Now, when you're creating a stair, especially in Comprehensive Studio and in reality, the two biggest things you need to worry about are your stair width and your riser and tread depths. So riser and tread depths, it's automatically programmed within Revit to be at 11 inches for your treads and between 6 and 7 inches for your risers, depending on the floor-to-floor height. Because not every floor-to-floor height is going to divide evenly into 7. But your run width, the width of your actual stairs, is extremely important because your run width is what determines how many people can move down that stair at one time. So how many people you can fit on a floor is dependent on two things: your stair width and the door width, right? Because it doesn't matter if your stair is 12 feet wide. If your door is only 3 feet wide, you can only get so many people in there. However, it is floor to floor, so you don't have to accumulate all of the floors. It's really just floor based. And so, rule of thumb that we typically use: 5 foot wide stair can accommodate 250 people. So 2 stairs, 250 for each. We can max 500 people on a floor, and that is the max you can do for a 2 stair situation. I won't get into too many details, but that's very important, especially if you start adding balconies onto your building, because balconies is an assembly space. Assembly space basically allows for a ton of people, so it drastically increases the amount of people that the occupancy will stand for. All right, so stairs. I'm not going to go into exactly how to build stairs because, again, you should know how to do that. But of course, you want to build the right amount of stairs. All right. And then what we typically do too, at least what I typically do, is I will build the stairs in the model, and then I will draw the boundaries of my the stair walls, the shaft walls around it, just because then I know for sure that the stair can actually fit. So if you have different height levels, you want to make sure that you're drawing both heights before you draw that. So I'm just going to do it quick. Again, this is not pretty. It really does not work well with my OCD, but that's okay. All right, so I have the stairs. If I go into my elevation, I can start to see the stairs. I have a video on here, linked in the presentation, that goes into how to do really custom stairs. So do not try and build stairs manually, like in Rhino or anything. That it's terrible. You can build really beautiful stairs in Revit just by using the family parameters and just doing a couple things. And I go into that a little bit. We were detailing the Kistefos Museum by Bjarke Ingels, and did some pretty funky stairs. So in a tower situation like this, and really any situation where you have the stair to stair per level is the same, what you want to do is use the multi-story stair tool that allows you to select all the levels in which you want these stairs to connect. And it basically acts like a group. So if you go and edit the stair within, so you have to tab in to edit the stair, but when you edit the stair, it will populate all the way up. And then also, if you adjust the height of the levels, the stairs will actually adjust with it. If you adjust the height of the levels, just be aware sometimes the stairs will do funky things, so you have to break it a little bit. But again, it's trying to set it up so that it is somewhat parametric and flexible to your project.
So it figures out the first floor.
So it can. So like if I did the first floor and then I'll do that right now. It's just you don't have the same level of specificity with it that you do if you know that it's the same height. So if I did select levels, and then, did all those, yes. Yeah, so it works. It aligns all the landings back up. But what it did is it pulled the where the landing or the floor landing is going to be. So it kind of shifts things back and forth. Again, sometimes it works fine for what you're doing. Sometimes it doesn't. What we typically do, we just make sure that it's the same stair, and then we control the atypical stairs separately. And once you establish the multi-stair, you can also disconnect levels in case one level changes and you want to make that one a unique condition. So like I said, you need at least 2 stairs, especially in a high rise. And I think you guys are doing mid rise, but again, if not, that's fine. So I am just going to mirror again using my handy dandy center line. And I'm going to do it again. The reason why I'm doing it again, and depending on your project, you might not have to do this, but right now, predominantly the doors that are going to be going into this stairwell is going to be on the south face for that stair. If I were to lay out the same door on the same side, you might not be able to accommodate the correct distance between exits. And so we most of the time will mirror it so that we have a door on the opposite side of the core. And that just allows for shorter distances for people that are on the opposite side of the building to be able to get to an exit. The code inspectors, the code reviewers also prefer that you do it like that. So now that I have my stair in the approximate location that I want it, there we go. What I will use is something called a shaft. So a shaft, again, it's pretty self-explanatory, but the shaft tool within Revit is a tool that will, you can have extend vertically throughout the entirety of the building or stopping at different points. And what that does is it cuts through all of the floor slabs and the roof slabs. So any floors and roofs. That allows you to be able to manipulate the extent of an opening within a horizontal assembly without having to go in and edit every single floor and every single roof, because that would just be a pain, especially if you have like 20 floors. So all you have to do when you're using the the shaft tool is draw it around the extents of whatever element you are cutting through. And remember, if you do have a, I gotta shift that over. But if you do have a, let me just draw it real quick. All right, so I'll hit check on the properties. So it's still selected, but under the properties, it has a bottom constraint as a top constraint. So again, you can adjust them after you place them. So I'm just gonna put it at level 1 and then just have it, be, actually, I'll put it at level 2 and then just have it be a little bit below and then go up to the roof, be a little bit above. And if I go into one of my elevations, so you can see here, now I can control both of those at the same time. And I can also adjust them however I need. So what I should have done first is turn this off. If anybody doesn't know the temporarily hide or isolate tool, super helpful. I have shortcuts to it. That's what I've been using. But underneath this little binoculars is a hide element. That temporarily hides it. That's what this blue box around the screen represents. And essentially, you can hide whatever you want just temporarily so that you can see stuff like below it. And then if you reset, it'll all come back. So that way you can just hide specific elements really quickly without having to go into your view template or your view properties and be able to manipulate it manually. Again, I want these to be on top of each other. And then reset. Then I think I turned. Yep. And then again, the nice thing too is you can, all you have to do is go into the edit sketch of the shaft and make any sort of updates. Any sort of updates you need. And again, you're not having to then go in and have to update if you're like tweaking, the shaft opening an inch. You don't have to go and do that for 14 floors. All right, so now I go into my 3D view. So I hide this guy real quick. So now those stairs are going through. Now, of course, you have to update your structural layout to accommodate those shafts. So your beams, your purlins are all going to respond to that and essentially be oriented around them. That's one thing that's really big in any sort of shaft condition, especially with stairs, making sure that your stairs do not come up to a landing and then there's a beam on top, because then people will smack their heads and you'll get sued. So you want to make sure that they're within a column grid. That way it's much easier for the structural engineer to frame around it, as well as you can use, so like we talked about last week, CLT panels can be used as shaft walls. It adds stability. They can act as shear walls. So if you wanted to, you could create your stair walls out of CLT panels and then use them as a structural component and actually have your beams abutting and actually resting, being supported by the CLT. I'm just going to draw it out of walls because time. Now, of course, you can, if you want, you can create a CLT. Do I have that in here? I might not have it in here. Oh, yeah, I do. You can create a CLT shear wall out of the basic wall component. Now, you're not going to be able to figure out the fabrication of them. It's not as technically specific as, like, say, actually drawing the panel width and locating them all. But it's a good way to quickly be able to generate that. And again, this should be covered in your comp practice, but you can create all of your wall assemblies directly in the family get the thicknesses that you need. I'm just going to draw really quickly. Let's see. How do I want to do this? I'll do that with center line. Now, of course, all those walls would actually stop at each column. They would, depending on what material it is, it might be structurally connected. It might just be connected by gypsum wall. I'm just doing this really quickly. Now, I'm going to do this pretty rough, and then I'll show you the other model that I spent a little bit more time putting together. So the other thing, so what we refer to stairs as are vertical circulation, and the other vertical circulation elements that you have within a building are elevators, also known as vertical conveying systems. So within the presentation, skip past it. So this is a really good BIM object, is a really good resource to find really nice detailed elevators within. Just be forewarned, a lot of them come in with a lot of detail, and there's a lot of parameters that you have to manipulate to get it to work with your buildings. Sometimes the simpler is better. But if you want to play around and see if there's something that will work for your project, go right ahead. I have one of those right now. These guys associate with the walls. And when you're doing elevators, just like you do stairs, what you want to make sure, and this is probably something I had done in the other model, make sure that it is out of the way of any beams. Again, so within a structural bay, it's generally okay. The structural engineer will frame around it. However, if you have an elevator in the middle of a structural grid, your engineer is going to not like you. So just make sure that it is out of the way. And within a building, as I'm sure your professors have told you or will tell you, so your building, depending on the height and the size, is going to determine how many elevators you need, as well as, that's weird, whatever, as well as the speed and the size, especially in larger buildings. We will rely on a elevator specialist who actually comes, whatever, I'll place it manually. Who'll actually come in, and depending on how tall your building is, how many people, and then also the type of building. So like, let's say we have a high-rise bank and you got executives on the top floor and they do not want to wait around to get up to an elevator. They might accelerate the speed of a certain elevator and actually designate it as the executive elevators, whatnot. All that to say, there's a lot that goes into elevator design. Work with your professors to determine how many elevators you need. And then in high-rise conditions, you will typically have two banks of elevators, one that is going to the lower levels, one that is going to the higher levels. I'm not sure. It really will depend on your project. What's that? Yeah, and yeah, 150,000. It really, well, 150,000, but it depends on the floors too. Floors really drive the amount of elevators as well as square footage. And then also a service elevator is going to be needed. So, especially in smaller buildings, you'll typically designate one of your elevators as a dual purpose passenger and service elevator. In larger buildings, especially in high rises like this, you would have a designated service elevator, one that typically will go all the way from your underground areas all the way up to the penthouse where you can service the equipment. All right, so yeah, elevators. And I'm just quickly going through. Now, in reality, I'm not going to do that here, but I just wanted to show like this is what typically a elevator layout looks like. This will be in the template or the demo that I put together already. Two things that you got to make sure of is at the base of your elevators, you're going to have a pit, right? So when an elevator goes down to the ground floor, it needs to be at the ground floor, right? It needs to be at level with the floor slab. But the elevator is not flat on the bottom. It has a ton of equipment, and also underneath, separate from the elevator, are all the equipment that both conveys it, as well as a bunch of safety springs and all that stuff at the base. So you have to make sure that you fit all of that underneath it. So pit needs to go underneath your elevators, and then a machine room can, depending on the height, either can go adjacent to the elevator at the bottom of the elevator, or in taller situations need to go above the elevator. So like for these low rise elevators, the machine room is going to be on the level above where it stops. The higher elevator, that's going to be up at the roof. And there's a ton of stuff. Elevators are kind of fascinating. Like for the high rise that we did in Uptown, the speed of the elevators also determine how high above the final floor it has to be. So they actually calculate, depending on the speed, how much distance it has to take to slow down to then be able to stop. Otherwise, it would bust out the roof. All right. And then, of course, I don't know why that did not copy, but you also need to have all of your fun mechanical, electrical, and um, basically all your infrastructure, as well as the restrooms. So typically restrooms will be in your core. Um, there's just you can put your bathrooms wherever you want on your building. In reality, you're going to stack them all so that all of your plumbing is going to be above each other. It just reduces cost. So I just made quick boxes. I'll get into that a little bit once I start to put together the occupancy. But as we mentioned, let me uh, cheat real quick. Oh, yeah, they are. So in reality, your walls are really only going to run between your floor and your ceiling and go up to the bottom side of your deck. Now, if you're modeling and you have something that is, on top of each other all the way up through the building, you can't just have it extend. But for what we do in practice, you need to, we typically will separate it and then we'll just group anything that's typical across floors and just populate it up. So I have populated those all to the roof. Right now I'm just going to extend it real quick, but I am going to take this opportunity to create a penthouse. So penthouse, unless it is in a condominium or an apartment, is not a pretty thing. Typically in offices, the penthouse is where all the systems, anything that lives on the roof is within. Now, your big equipment typically will live outside the core, but like your electrical equipment, a lot of your plumbing infrastructure, especially in taller buildings like this, will all be within an enclosed penthouse space, as well as your elevator machine rooms, your overruns, and then the stairs, right? So you can, and I just created a new level for the penthouse so that I have all of my floors linked.
This building has a nice penthouse.
Yeah, sure.
Dubois, yeah. Because if you look at it,
oh, this one. I thought you were talking about this one. I was like,
oh. This building maybe too.
Yeah.
But if you all notice how the screening in the parapet actually is a whole floor, it hides the air conditioning unit, it hides the elevator penthouse. You should look at it from the front.
Yeah.
Your building should be like this.
Yeah. So this is what you should not have your penthouse look like.
Okay. You'll fix it later, though.
Yeah, I mean, I was going and I did the massing, and then I was like, oh, I should probably show them what a penthouse looks like, so I like added it. But yeah, in reality, right, like I am going to extend the massing, the form, especially something like this unique, extend past it, have the facade actually extend up above the roof, and enclose it so that from the ground, from far away, it all looks like one nice uniform building. Yeah, but a lot of buildings unfortunately end up looking like this.
Go up one more floor with your skin.
Yep.
I know, of course, in reality, you're going to fight with your client about the cost of that.
Yeah.
But you're responsible as a good architect to clean up the skyline and not have these concrete blocks.
Yeah. And again, too, I mean, if you wanted to like really exemplify, like it could be another formal element too. But again, no, that's fine. There's gonna be like this box on top is just gonna have those like core stairs, elevator, machine room, electrical room, and then the connection to your mechanical shafts. But on the outside, at the perimeter, are going to be these, well, depending on the building, giant pieces of equipment, and they're not pretty to look at. So there'd be screening around it, all that good stuff. Where was I? Yeah, so just make sure that your roof is accessible. So that means that you have to have either a stair extend to the roof or a ship's ladder of some kind, preferably a ladder for all of your maintenance people. And then make sure that you have clearance above your elevator for the machine room and for its runoff. So again, this kind of looks a little bit messy, but that is okay. I'm just going to quickly check my notes and all that good stuff. Within the Autodesk family inserts, you can find a lot of that equipment if you want to be really specific. But ultimately, what we typically do is just put massing in there. We'll get the dimensions from the engineer, and then we'll just put massing in there to make sure that everything is appropriate. All right. So after all that good fun stuff, so now that we have the majority of the building elements modeled, we have a general floor plan. You can do a ton of other stuff. Then we have to do enclosure. So again, you guys should have gone through all of your standard Revit walls and curtain systems, all that good stuff. But I just want to show the two elements. So using that conceptual mass that you placed into the building, you can do either your basic walls, and so just like you did with floors, the mass floors, you can do wall by face and have it be associated with one of your massing faces. I think I did. So really quickly, those are on there. I just did a really simple grid pattern on the face of it, but of course, depending on what you're doing, you can manipulate that however you need. realistically, it'd probably be a curtain wall system of some sort. And then curtain systems you can do in a very similar fashion. Now, just be aware that sometimes the direction of your faces are going to be flipped depending on the face. So what I typically do is I'll just go one at a time. And as you can see, I built 2 different curtain systems. That way, it has you are able to manipulate it however you need. So I'm just going to do this guy. So the curtain systems act just like a curtain wall. So you can either determine the amount of divisions within the family parameters, acts just like a curtain wall. I have not defined a mullion just because when you add mullions, all those mullions are individual components and faces, and it makes the size of the model gigantic.
So that's just the grid right now.
Yeah, it's just a grid, and each grid has a glass panel on it. It's just representative right now. So these are 4x10 spacing. You can change that however you need. And then you can also, this one is, if I, come on. And this is not, I don't know why it's not working.
And he likes your balcony.
Oh, thank you.
But I don't want to detail the skin. Because it's just going to be a nightmare. That would be the junior draftsman.
Yeah. I'll get in that. Yeah, I have an hour, so I'll get into that a little bit. Yeah, I mean, in reality, right? Like, if you had a facade like this, you would hire somebody like this, and you and Front Inc., her old firm, to develop the details of the facade. But when we get into detailing, like one thing I emphasize: look shit up and try and copy it as best you can, because your students, you have absolutely no idea for a lot of this, like how to actually put that together. So having to look at how people have done it before will make your life a lot better. All right, so you can also change, instead of setting the dimensions of the spacing, you can set numbers depending on how you want it, and of course change the angles. I'm just going to set this to the second system just so that it is reflective of the panel. I think this is where, yeah. So see how on the one side it's horizontal and one side it's vertical? That's because the way that Revit is currently reading the UV structure of the surface, it's rotated. I'm just going to leave it like that for right now because I need to move on. So when you get in your enclosure complete and you have your core elements and you have all the other kind of elements within your floor plan established, one part of both this course as well as in reality is running occupancy calculations. So in Revit, there are 2 different components that do very similar things, but one is much more important than the other. So in your architecture tab, you have rooms and you have areas. So rooms are typically used in interior layouts. Our interior designers almost use this exclusively. It automatically generates a room based on the boundaries of the walls that is surrounding it. And then, of course, you can extract. So if you do, they throw things around. So like the tag room is here, but then all the other tags are in another component's pain in the butt. But anyway, you can start to tag. This is a really nice way of starting to create visual diagrams of your spaces, and it also calculates the interior area of that room. So you can see all these have the square footage associated with it. If we look at the room, so if you actually select the room, you can see that the boundary is of these inside face. It's taken from the inside face of the walls. That's great for doing interior space planning, seeing how much square footage you have within an office or within a lobby. However, for calculations, for occupancy calculations, that is not acceptable to the jurisdiction. They have very strict requirements for what side of the wall between two different occupancies you can place the location. And so that is where things like areas come in. So areas require a specific plan, a view plan called an area plan. So if I can't draw areas in your typical floor plans, I have to go into my view, go to plan views, and just like I would with a floor plan, I then go down to area plan, click that, and then of course create it for whatever I want. So I'm just going to create it for level 1 for right now. Always hit no. Revit's great in a lot of ways. Placing area boundary lines in the correct location almost never works. So it's going to pull up a blank area plan, and then you go back to that initial tab, and then before you try to set an area, you have to create an area boundary. So it is not going to recognize walls as part of its boundary. It is only going to recognize the area boundaries as the thing that it justifies to, because the location of those lines are very, very important. So you have to draw those all manually. Yep.
Dependent on use.
Correct, but it's dependent on use, and then it's also like it's calculating gross square footage as well. And so there's a lot of requirements based around it. So like, I think if I remember correctly, so like for Ally Charlotte Center, and I'll show you the life safety plan of that in a second. Like it counts the stairs as part of the occupancy for some reason. Sometimes it does, sometimes it won't. But just know that when you're doing these types of calculations, especially in practice, less so, but still important within academia, you need to be very specific about where those lines are being located. There's also very, very strict rules on where you can put the location lines at the exterior. So like for solid walls, it goes to the back face of the wall. So like with a drywall, it would go to the back face of the drywall. But then with glazing, it actually goes to the back of the face of glass. So it goes in and out and all this stuff. In any case, so once you draw those area boundaries, sorry, I'm in two thoughts at once. You can go to your area. And you can also, apparently you can create, that's a new one, but you can create an area plane directly from there. You select, and then you place the area very similar to the way that you would with a room. Now, the one nice thing about areas is if a series of rooms are all the same occupancy classification, you don't have to draw boundaries around every single one. You can basically just encapsulate that entire area as one large space and just use that square footage. So it does have some benefit. Within the template that I'm sending you, I've integrated some, and as long as it's okay with you all, I've integrated some shortcuts. So it's basically pre-built schedules that have all of the building functions and occupancy classifications built in, so that when you select an area, you can just go to occupancy. Oops, maybe it's going to call me a liar. Oh wait, no, those are rooms. Why are those rooms? Oh, I went back to the wrong. Plan. That's the very specific thing about. Oh, and that's the other thing. So when you're doing your area plans, one good thing to do is just turn off your rooms so you're not selecting the wrong thing. All right, so areas. There we go. All right, so under parameters, you have your key function and use. So I'm just going to say business gross. And then key occupancy, so it's class B. And then I'm just going to say for these, both they're, MEP, equipment, back of house. So I'll go down, oh wait, no, sorry. Accessory, so storage areas, mechanical spaces, etc. And then down to S2, I believe. So that is a piece of it. So all those are being pulled from these two schedules. So each of these so classification is really just for the building reviewers to be able to see what your building classification is. The function of space they use, they all have load factors associated with it. So when we start to build area schedules, you can basically plug those into the schedule and have it calculate the maximum occupancy dependent on the square footage of your plant. So to do that, you go to view, schedules. Now schedules are one of the biggest pains in Revit by far. They take a while to get comfortable with, but they are extremely powerful to be able to extract parameters and information data from your model and be able to utilize that in different applications. So you will essentially specify, once you select schedule, it's going to ask you what elements am I pulling the data from. Otherwise, you would have to filter through a ton of different parameters, and that's not fun. So what you want to do, so next to each one of these areas is a little parentheses and then a name. Those are associated with the actual categorization of the floor plan, of the area plan. So see how in the browser you have area plans and then life safety. So you want to make sure that you are clicking areas life safety. That essentially allows a little bit more specificity when you're doing multiple area plans. So we don't just do area plans for life safety, we also do it for gross building square footage. So we go to the outside perimeter, also do it for leasing plans. So the developers want totally different area plans than the jurisdiction. So this is going to bring up this properties, and what you have in here are all the different parameters that are encapsulated within an area itself. So where all, like we specified the building function and the occupancy calculation, those categories are also built in here. So these are those two. So what you can do is you pull in all the types or all the parameters that you want the schedule to utilize into the schedule. You can organize. So right now, if they're listed top to bottom, that means that they're going to be located left to right. So just one thing to note. And then I'm going to press OK. It's going to create a new. Now, it brings in the area, brings in the occupancy, all that good stuff. I haven't named it. I'm just going to name it office. There's one nice thing too. If you have a bunch of stuff, you can just manually manipulate the name there. However, I don't know. Let's see. I think I pulled the wrong thing in. Hold on. Here we go. Just gonna pull this up. There we go. Okay, so now it's pulling the area per occupant, the load factor that it has within this schedule, into the new schedule that we just created. And this is all great, but it's not giving me the quantity, the actual occupancy of each space type. So what we can do is go back into fields, And instead of trying to bring in something, what we can do is actually create a new parameter that is a formula that takes two or more parameters, and you can do different mathematical equations to it. So it's this formula guy down here. So it brings up this. So you just put in the name, occupancy, formula, common number, yes, and then you can bring in the two different parameters that you want to have done. So right now, how do we get our occupancy? Well, we don't multiply, we divide. So we take our area, we divide it by the load factor. That's how we get our occupancy. Oh, that worked perfect. I struggled a while ago to get that to work. So now it's bringing in the occupancy, and it's actually calculating based on the area of each space type how many people can fit within it. Now you can do a lot of different things within the schedule tab. So you can manipulate the appearance, the graphics of those if you want to create a really nice, pretty schedule. The other thing that you can do is you can change the headings. You can actually like hide parameters. So like if you need it to do a specific formula or be able to categorize things in different ways, but you don't want it to actually be visible on the sheet, you can hide it. And then also, so see how our occupancy has 6 decimal points associated with it. So we can change the field format, so we can actually round it to a specific place. So just for y'all's knowledge, we do 2 decimal points. So that is, we always are going to round up, but when we're adding them all together, we add the decimal points as well. And then that shows the reviewer that we're not cheating, that we're using the correct occupancy. And then once you're at the final, you then have to round up. And again, you have to round up no matter what the decimal point is. If it is 0.01, that is another person. So you have to add a round up to another one. And then let's see, also under formatting, you can have it display totals or mins or maximums. So for both the occupancy as well as the area, I'll just have it calculate totals. And I need to have it, oh, there we go. And then you can organize it. Yeah, so I can organize it. So you can organize it in different ways. This is also where you can get different footings. So totals only. Hey, there we go. So, so now I have not only the total amount of people within that specific floor that I have to accommodate and get out of the building, but I also have the total square footage of the building as well. And then, of course, you can populate this across the entirety of the building, do the totals. But for life safety, all we care about is each level individually. So while the owner might want to know the total and the jurisdiction will want to know the total square footages of all the different occupancy classifications. And the occupancy itself, the total amount of people, is really only dependent on floor to floor, because that's how many people you need to get out of that floor and how the stairs are utilized. Okay. I know, really fun stuff talking about how to calculate occupancy. I just wanted to show again, so this is okay. Yeah, so this just goes through all of them. Oh, I'm dumb. This wasn't part of that. So this is the life safety plans for the office tower that we did a couple years ago. So as you can see, we visualize and show the boundaries of the areas for the jurisdiction so they know exactly where we are pulling all of our square footages from. We also use, this one doesn't show it as well because it's really only 2 occupancies, but we typically will use different hatch patterns to show really visually contrasting between each other what different types of spaces are what occupancy. So especially when we have assembly spaces, we will use a different hatch pattern. And then again, like right from Revit, we are using schedules to be able to tabulate and calculate the total square footages of each floor as well as the amount of occupants. And it looks like, yeah, that looks more correct, 29,000 square feet. I'm gonna have to talk to the PM about this tab. Definitely not 2,000. All right. What is next? Any questions? Yeah.
Is this being recorded?
Yes. Yeah.
Because I missed one step in
Yep.
Yeah.
Yeah, this was not designed to be followed along with, and that is why I record all my tutorials. And so when I teach the class, I pre-record it, and then I basically in the class I will like basically give over the recording to y'all and have you follow it at your own pace. Because yeah, when I first started teaching, it was fine when I had like 15 students, but after it got to 30. The amount of questions I get and then the interrupt, it just doesn't work. So yes, all of this is recorded. All of the like the YouTube tutorials, they go way more in depth. They walk you through step by step. I skipped over a ton of stuff just to be able to make sure I get through it all. All right, so and again, I will have the full model that I built over the weekend accessible to y'all, so you can look at it. You can steal components from it if you need to. Okay, so yeah, just don't have your final building be look too similar.
In the beginning, you showed us how to set up the grasshopper within Rhino inside Revit. That grasshopper, is that also going to be?
Yeah, I'm sharing the model, the Revit template, the Rhino inside, like the grasshopper scripts, the families. Like so, there's some families that I built custom, so I'll do that. And then the presentation, obviously, some other things. But yeah, I will send that all out after because I know. And yeah, this is. I started using Revit when I was a sophomore in high school, so I have like way more years of this than I know than I'm comfortable with. All right, where am I? Okay, sheets. So how we actually get buildings built are sheets and subsequently documents, right? So this is how we submit this to the jurisdiction to get our permit. This is how the contractor and the builders actually like figure out how to build the building. So again, I'll walk through exactly how to do this, but I just wanted to show. So we use sheets in really primarily 3 different ways. One is to create a blank. Essentially, it's just the outside boundaries of the sheet, but we create the different size sheets so that when we go and print a view, we know that it's scaled correctly. We'll do presentations. So we do actually set up drawings in a way that we can use in presentations. I'll show you how to do that. When I was in comprehensive, well, not my first comprehensive, but in my second grad year, my third semester, I literally set up all of my drawings, my plans, my elevations, my perspectives, except for the renderings, in Revit. You can do really graphically beautiful drawings in Revit. You just have to know how to manipulate the settings to do it. I literally was able to detail as much as I possibly could of the model in Revit and then directly export them the night before. And all I did within Illustrator was populate the drawings with the renderings and do fancy layouts and fonts and all that good stuff. But all the drawings were directly out of it. So I didn't have to spend countless hours in Illustrator changing line weights and filled regions and solid, all that good stuff. Okay, so those three. The final, of course, way that we use templates and sheets is the construction title blocks, construction sheets. Your firms will all have their own unique sheets. For today, I thought we had, did I not have? This is in the wrong place. But this is a sheet directly from the Ally Charlotte Center. So the facade was very detailed. It had a ton of different components. So not only are we using not only are we showing two-dimensional details, which you predominantly see within construction documents and sections and plans, but we also are showing 3D representations because we are trying to convey to the contractor exactly the sequence of construction. That is somewhat iffy to get into, but again, what we're really showing in here, let me see if I can zoom in. What we're showing in here is all of the different parts and pieces that need to be within this assembly for it to function correctly and be up to code. So the fire safing needs to go in, that bottom piece, the horizontal exoskeleton. What we also start to show is the sealant. So visually showing them, hey, you need to be able to seal. You need to be sealing this as you're going, and then finally starting to put in the topmost precast, not only with the sealant but also with a ton of the fire rating and a couple other things, and then finally finishing with the curtain wall, and then those relate back to specific, very detailed details. So again, these are all to convey how the building is supposed to go together. It's supposed to convey the assemblies that we need and the orientation, the quantities, and the depths required. And then how it gets put together is up to the contractor. That's what's called means and methods. If you haven't heard about it yet, you're going to. So we can't tell them exactly how to build it, but we need to be able to tell them what needs to go into it and how. And what and where and all that good stuff. Where am I? Okay, so going back to Revit. Close out of this. So before you ask, yes, I'm going to provide all the sheets. So up here under View tab is your sheet. It'll pop up with all the title blocks that are loaded into your project. You can, of course, go in and load one if you have one built or if you have one from another project you're borrowing, or if you're loading in one that I provided to you, or you can use one that is already built. Now, if you create the sheet and it's not the right size or you need to change it, of course, you can just go in and change it from the drop down. So we're just going to use a blank for right now. And then populate. All right, I am not going to waste time doing a ton of this. What I am going to show you is, and I think it was back. So you can go, I basically went from the one on the left to the one on the right in about 30 minutes, just changing some view templates, visibility graphics, and changing out the types of grids, levels, all that good stuff. So you do not have to stay. I think I cover the majority of all the graphic components, line weights, all that good stuff within the YouTube tutorials and within this presentation. I'm not going to go into that right now. What I will at least say is that the Revit components that come with things like levels, things like grids, section markers, and elevations, you do not have to keep those. You do not have to stay with those very ugly, very just not pretty visual symbols. You can change, you can create your own just by going into the families of each. So one thing that some people might not know where to go, because again, Revit Autodesk likes to hide things. So you can edit type and then be able to manipulate all the different parameters. So like you can change the color of the line, you can change the line weight, you can change the actual line type, right? So you can change it from just a simple dash to a very custom one if you really want to. And then you can also change the circle head. So you can, if you want to, turn it off essentially, and then just add some really nice custom special font in Illustrator, you can do that. You can also build your own. So all of these, now while you can't edit the annotations directly in the type properties, the grid properties, what you can do is, if you're in 2024 or later, you can actually just type that in and find it under the families, and then go in, right click, and make sure that you're right clicking the thing that has the drop down next to it, not the actual drop down itself. That's it just won't work. So if you go into edit, it's going to bring up the family, and then this you can manipulate however you want. So if you don't want the circle, you just want the label, you can do it there. If you want to change the font, you can go in, change the font, you can change the size of the font, you can change the color of the font, all that good stuff. I have no idea how this is going to look. All right, that's different enough. And then you can load that back in to, the right project. Now, just remember that if you're loading it back in, it's going to overwrite anything you have. And then, see, it does have some funkiness when it comes in. So, yeah, I think you can change.
It's like if you got rid of the bubble.
Yes.
It just like takes it to the center of the object.
Yeah. Whatever. Yeah. So what you could do is you could add an invisible line at the bottom of the, and you could basically turn that circle actually into an invisible line, which an invisible line is just a line that's colored white. So just be aware of that. But you could turn it into a white one, and then it'll have the same parameters, the same buffer zone around it as you want. Again, all that to say that you can customize all of the families in here, including the annotation families, to be as visually aesthetically pleasing as you want. Same thing with levels, right? So that's kind of crappy, but I pre-built this one. So again, got rid of the weird, ugly cross, center, what is that called? Bullseye. And then change the font styles and color of both the main level name as well as the elevation. Also, this is one thing I forgot to mention before, but this is how you can change from the true elevation above the survey point, so wherever it is actually above sea level, to the project base point, which will give you the elevation above the first floor. So at the first floor now we'll say 0, and then of course subsequently above that. The one other thing, so within, and this is true for a lot. Oh, this is what I was going to actually say for the title block. So you can create your own title blocks. So that's how we've created all of ours. That's how everybody creates theirs, is they go into the sheet family, and then you can add different parts and pieces to them. So you can do all sorts of visual representations, lines, filled regions, text. But one thing that is very unique and is very helpful is using labels. So labels act just like your text, but instead of having to manually type in and edit them, you can actually have them be tied to a parameter within the project. So if anybody ever wonders how like it knows the sheet name and the sheet number and it populates it in the specific area, that is all from the labels. So you put that down here, and of course you can change the font, you can change the height, change the color, all that good stuff. And when you load it back into the project, it will associate whatever parameters associated with that sheet to the title block. So yes, I'm going to override it. So of course it's called unnamed because we haven't actually named it. But if we go to the sheet in the project browser and rename the sheet to demo, so now it changes to demo. You can do this with the location of the project. So that's how we add locations to all of our sheets, because wherever you establish that within the project parameters, it then populates through all of the sheets. Things like construction, permit date, revisions, all that good stuff live within that. Okay, all right, I got 20 minutes. So the last couple things I'm going to talk about are detailing. Yeah, perspectives. Again, that is within the videos that I have online. But perspectives, you're going to do renderings, but sometimes you might want to do perspectives for more of a diagrammatic representation of things. Maybe you want to take just the structure. Sometimes it's nicer to utilize a more drawing format rather than trying to do every perspective out of renderings, like we did in the Ally Charlotte Center. Okay. Yeah, well, so anything that you want to help explain how things are supposed to look. So in reality, when we use 3D axons or 3D perspectives in any of our documents, we put a disclaimer on there that says this is not for construction, because sometimes contractors just take it upon themselves to, take everything as 100% truth. So like we had something not modeled 100% correctly, and then they built it like that instead of according to the detail. Anyway, all right. So sections. So you're gonna have to be doing a wall section. Everybody should know how to do sections. And again, you can make sections as pretty as you want. When you're building sections, make sure that you're setting the extents of these sections correctly. So not only depth, right? So you either do or don't want to capture a certain amount of distance away from the cut line, as well as how far, right? So one thing that you can do in Revit, which is really nice, is you do not necessarily, if you're taking a wall section at the same place, you can use these view breaks to be able to break the section into multiple pieces, and then you can take, you can basically have a section detail at, and be sure not to accidentally connect it back together, but you can have a section. So you can have like a typical intermediate section, you can have a base section, and then you can have a parapet section detail, all within the same drawing. So, you can do that if you'd like. That's how we set up ours. And then when you're doing these types of details, of course, you want to make sure that your scale is set correctly. So make sure that whatever detail you're drawing, it's representative of the the scale is representative of the detail. So you want to make sure that the detail is large enough so that you can actually see all the detail and the components within it. Another really helpful thing to do is turn the display model to halftone. All right, so that basically turns all the model components to a gray tone. It allows you to see all of the detail components much easier and basically allow you to see where you've placed and drawn versus where the model still is. And I'm going to flip to my other model real quick and show you the detail. All right, so I did this pretty quickly. And I say pretty quickly, it still took like, I don't know, an hour and a half. But these were stealing components, stealing assemblies. I doubt this would actually be buildable, but at least gets all of the assembly components together and satisfies all the building requirements. So on this building, I have an exoskeleton, I have a curtain wall system, I have a structural system, and now I have to figure out how to make those all work together. So I mentioned before, if you go into the Autodesk family, you can load a lot of detail components. So all of those are within the detail items. So all these components live within here, and they are all built around the actual size, dimensions, and qualities of the components that they're representing. So you can actually load in the glulam families, and then if you go to annotate and component, you can start to place those in. Now, sometimes when you're loading those in to your view, line weights, hatches, they might not be exactly what you want. So you can actually go in to each family and edit it. So all the detail components are just 2D line work and hatches that they then manipulate, put parameters around to make it more parametric to be able to scale and whatnot. So all of the slices, everything, while in the project, it's one nice component. Within the family, it's essentially made up of lines and one big hatch. So if you want to change the line weight of the outside boundary, you just edit the hatch. You go in, change the line weight to, detail items, whatnot. It'll make it smaller. Of course, personally, I don't like that, so I'm just going to go back. Now, if the one thing that a lot of people run into when they're editing within families, and they probably typically just give up on, is within a family, it's only going to have the line types that were brought in for that family. So it does not have a lot of variety, a lot of selection when you are creating it. So, and what Revit did, which again, I just don't understand why, but it's Autodesk, so whatever, is within a project to be able to create, edit, and manipulate line work, you actually, you go into manage, additional settings, and then line styles. And that's where you can actually go in and manipulate all the different line types. You can create new ones. You can put different line patterns on, colors, line weights. But within families, they were like, we shouldn't put it, even though it still has additional settings. When you try and click on it, it doesn't work. So they literally try and fake you out. However, you can still add line types to your project. It is under object styles. So if you want to create a new line type, you can just create line and then put whatever line type, whatever color, whatever line pattern on there, and then associate that to whatever element you're putting on there. Okay. The other thing that I wanted to show when it comes to creating graphics, again, I'm not going to tell you exactly how to build sections because each section is going to be different from one another. But you want to have perception of depth. You also want to have really good line weights to be able to differentiate where you're cutting through something versus where something is directly behind it versus where something is farther behind it, right? So like the column probably could be like, I'll probably add like a 2D line in there just to make a really faint representation of it. The beams and purlins are, the purlins are being cut through, the beams are going across. I've added a secondary beam in to then capture the curtain wall. And then again, the model components, and the reason why we use drawings is because model components can only encapsulate so much detail, and you can only be so specific with a model. So when you have crazy design schedules, crazy long design schedules like Frank Gehry or Zaha, and you can like spend 8 months on conceptual design, they actually do use the models with the contractors to go back and forth and actually build the building with. But we don't have that amount of time, so we still need to do 2D. And again, you can only do so much within a certain amount of time with the model components to get it close. So for instance, right, this grid, it's relatively where it needs to be within the model from a visual standpoint. But in reality, I'm going to have to shift that down. I'm going to have to manipulate it. Same thing with the curtain wall system, right? Like the curtain wall system was actually like 7 inches inside where I currently have it drawn. And that is really where detailing plays a really big role within the design process. Is we'll lay out a 3D model, get it to visually look right, all that good stuff. But then we'll start to actually layer in structure, mechanical, and start to detail all of the assemblies and start to adjust the model components based on how the details are actually coming together. Because you can't figure out everything all at once. So once we start to establish all the relationships of all the components within the detail, then we start to manipulate, the exterior walls, where the mullions are, all that good stuff. So, the model is representative of the detail. And again, we don't add all the detail into it, but like we would likely take that structural component, move it down. We would offset the curtain wall system so that it's in line with the where the detail needs it to be. And that all plays a factor when structure is laying out their slab edges, where they're laying out their exterior beams, columns, all that good stuff. And also when we're factoring in occupancy calculations and when the GC is creating shop drawings based off of our elevations and whatnot. Okay.
Can I just ask?
Yeah.
Just for clarification, as we see the model starting off with the overall form, then you're making the Revit model from that kind of the envelope. Right?
Mm-hmm.
This part is on the long side of the building, and it's cantilevering beyond the.
Yes.
Is the CLT holding that edge?
Yeah. No. So realistically, there would be within the representationally in the model, right? Like these beams. Realistically, there would be a beam behind that would connect. This
CLT is running which way?
It's currently running
perpendicular to the purlin?
Yeah. Now again, no. Yeah, no, opposite way. So yeah, so the purlins, it's running perpendicular. The purlins run perpendicular to the main beams. The CLT runs perpendicular to the purlins.
Yes.
Yeah.
So you could cantilever that.
So you can cantilever it.
Yeah.
Can you cantilever it and then support a curtain wall system from it? Probably not. It all depends, right? Like, so you could oversize your CLT, you could oversize your purlins, you could put a right. So like, if you really wanted to, you could put a diagonal brace between the perimeter and the column and brace it that way. Because also, right, like this is your most far, like the largest distance away from your primary column grid. At the base and at the top, you're really not worried.
But so to support that, you would really just want to take those beams.
You'd take the beams all the way out. Now, yeah, and then again, you would probably also brace it in some way diagonally to make sure that has stability. And that's the type of details that you got to figure out. Yeah, and one detail that I put in here that relates to the direction of the CLT. So the CLT is really easy and is I mean, it's not meant to be cut, but it can be cut in the short direction. So right now the nice little like side detail that Kevin really liked. So that floor slab is currently horizontal. The other model, it was following the mast. What I did was straighten that out. The reason for that is because all the CLT is running this way. So along the long direction of the CLT panel, you don't want to have to like go in and try and cut that. You really want to save and try and minimize your fabrication to the most minimal edge. So they can do that really easily with the fabrication equipment that they have. They'll just run the CNC and they'll have a visual model of the edge condition. So again, those are some of those tectonic things that you need to think about as well. It'd save a ton of money, save a lot of fabrication time, and work with your structural system.
These are important questions to kind of like keep at a large scale because, like, I like the shape of that facade you're making. To do that, you have to create the cantilever, which is exciting. You know, we've got a number of groups that want to create exciting cantilevers, right? And then also you want to express the wood at least on the inside along that long facade. But can you express the wood on where the structure is exoskeletal, like on those balconies that Chunky likes?
Yeah.
Or will you have to cover that up, you know, in order to protect it, right? To protect it. Yeah.
Yeah.
Well, the wood acts kind of as a thermal break, right? It allows you to. It's not like steel.
No, it'd be better. I mean, there'd be a lot of detailing between that. I mean, yeah, this whole thing to detail would be.
But just in terms of weather,
insane. But yeah, whether like you'd have to encapsulate all those beams, it would be a lot. So what you would realistically do is probably create like one. I mean, again, you can look up different details, different connection details.
Yeah, but I think the lesson there, because it's so easy to do in Revit, is that you're thinking that the inside expression of the timber should be on the outside, but it can be like the edge of the slab, because that material has to be protected some way from the weather.
You can have it be exterior. Now, the pain of that form is just the curvilinear nature of it and the amount. But we expose exterior CLT and glue lam all the time. It's just the way that you have to break it. So, yeah, depending on like the environmental conditions, you either have to like truly break it or you do different things to wrap it and protect both in and outside. I just want to show, like, as you guys are developing the wall sections, to not like get overwhelmed. So this is the one from my comprehensive studio. So starting off with just really simple floor assemblies and the facade, and then starting to do more detailing and figuring out specific connections, and then finally layering in like the systems, your sprinklers, your MEP, how you're distributing buildings. So we did castellated beams. And then don't judge me too hard on the graphics. That was not me. But putting in a little bit more of a representative
So you have to tell them what you're using there.
So these are so we did ETFE pillows. The facade. Yeah, if you wanna, I'll open this while I am. I could not find the final wall section. It was driving me nuts. But I did find all the Revit models. Of course, none of them had the final wall section in it. But the reason why I pulled this up was because Uh, I did not develop that detail on my own, right? You use references, so the references are your professors give you precedent. I mean, you reference precedent, right? Figuring out what the different layers are, how they actually approach these types of things. So, like digrids, it looks like the facade is on the exterior. In reality, it's behind the glass. They just do an articulation with a different type of metal cladding or decoration. The last thing, sorry, this is the this is the.
I think the cool thing is that you experimented with that, right? You didn't know exactly how to do it at that particular
Yeah,
time.
I wouldn't recommend it.
Yeah, yeah. But I think in terms of like trying to innovate something, I just wanted to get the students this message that I think you can take some risks. You know, even though all these details look like they're figured out, they're still diagrammatic, right?
Yeah, it's really just to convey like the performance, right? Yeah.
The intention.
Right? So like all the ETFU pillows, they had to have air going into them. They had to have clip systems to them. We had to have a gutter.
They had lighting and they had to have the mechanical filtration.
Yeah. Now we had the facade was super crazy. The core was like the most simple thing you ever saw. All right, one last thing, and then I will skip the rendering part because I'm sure you guys have already started playing around. So there are two different ways. So all of these little patterns that you see on the screen, those are generated using, you can generate them using two different components. So the first is under the same additional settings that you have to access the line styles within the project, fill patterns. So this brings up two different types, drafting and model. So drafting will be at a specific scale depending on the scale of the drawing. So it's actually going to manipulate itself to be the same size no matter what the scale of the drawing is. Whereas model is actually going to be at true scale. So the model we typically do for like brick patterns, for tiles, things that we have a nominal dimension for that need to be that nominal dimension. Whereas drafting is typically for things like concrete textures or like aluminum, whatnot. So to edit these or create new ones, that's all down here. When you're doing manual, you're really limited. All right. So unfortunately, you really can only do orthogonal orientations, patterns, either parallel lines or adding crosshatches. You can change the spacing of the two. You can change the angle of the two, but you're relatively limited. Now, uh, before Revit came out, you'd have to like use these really crazy softwares and actually write code for the patterns. Revit has now allowed you to just draw. God, my voice is killing me. Draw the pattern itself. So if we just do, so what you want to do is just create a rectangle of some sort. Remember that these are going to tile for over itself. So just be aware that if you want something to be seamless, you need to make sure that you're drawing it seamless. So I'm just going to do some funkiness. So what you can do is you can highlight either you want to highlight the lines that you actually want in the pattern. So if you don't want this outside box, you're just using it as a reference, you can do that. Draw it to scale. So if you want a model component at a specific scale, draw it at that specific scale. And then you can go into Revit, go into Make Pattern. It'll bring up this window. Then you can put in a new name, test demo. You can specify whether you want to be a model or a detail pattern. So a lot of times we do this for model components. If we have a custom metal panel design, it's kind of crazy, whatnot, we'll create it, or we'll create these new. And then again, you can do different variations to it. But essentially, then you can create the pattern. It's going to ask you, this is very important, to bottom left and then top right. So that's making the extents of the um, rectilinear pattern. So again, if you don't have model components in this space, but you want it to have space, make sure that you select it, press OK. And then if you go back to, well, if you go into any element that requires a, if we go into an element, let's just change this. So let's say I want to have this be this new pattern. And then I called it what? Test demo. So test demo. So it's going to come in as a custom pattern. You just press OK, and then when we draw it, so now it comes in. Of course, what you would use that for, I don't know, but custom metal panels, funky, very unique custom layouts, tiles, all that good stuff, like stacked tiles or bricks, right? You can't build that in the native Revit hatch elements. You have to build those from scratch. That's actually how I built the CLT. Oh God. That's how I built the CLT pattern. So this is one component. It has all of the different layers of the CLT panel. The horizontal that has the cross in them, that I just built because I knew those pieces are 5.5 inches wide. And yeah. All right. I think that's where I'm wrapping it up. Yeah. Woodworks. I think I mentioned this before. Woodworks also has details on it. So use that as a resource. Those have all the typical details. And yeah, rendering. I have a video on that. It goes through all the different parameters that you can manipulate for realistic renderings. So I think that's it. I probably missed something. If anybody has questions after I send out all the the presentation and the different pieces and parts, just let me know. Give me an email and I'll try and help. Right, thank you. Happy weekend.
She buy you dinner. She like give you a quick drink.
She paid me a lot of money for a couple of years, so
You're still working on like
that's why like all those everything I did in there was either 45 I had to Oh, Balkan architect.
Yeah, yeah.
Yeah, and I am.